What do you understand by quarks and leptons? Quarks and leptons are the building blocks of matter. Quarks are the basic building blocks of protons and neutrons, which make up the nucleus of an atom. Leptons are elementary particles that do not interact with the strong nuclear force and include electrons, which orbit the nucleus. These two categories of particles form the basic structure of all matter in the universe. What are the benefits of quarks and leptons? The study of quarks and leptons has greatly advanced our understanding of the nature of matter and the fundamental forces that govern the universe. This knowledge has numerous applications and benefits, including 1. Particle accelerators. The study of quarks and leptons is carried out using particle accelerators, which have numerous applications in fields such as medicine, industry, and energy. 2. The development of new technologies. A better understanding of quarks and leptons can lead to the development of new technologies such as high-energy lasers, computer chips, and advanced materials. 3. Advancements in medical treatments. By studying the behavior of quarks and leptons, scientists can gain a better understanding of how diseases like cancer and Alzheimer's develop, which could lead to the development of new treatments. 4. Improved understanding of the universe. The study of quarks and leptons helps us understand the structure and evolution of the universe, from the smallest subatomic particles to the largest structures in the cosmos. Overall, the study of quarks and leptons has far-reaching benefits for various fields and has greatly enhanced our understanding of the universe. What are the drawbacks of quarks and leptons? There are no known direct drawbacks of quarks and leptons themselves. However, the study of these particles can be challenging and requires significant investments in research and technology. Additionally, some of the applications of this research, such as particle accelerators, can be controversial due to the high cost and potential environmental impacts. Additionally, the study of quarks and leptons often requires a deep understanding of advanced mathematical and physical concepts, which can limit the number of people who can contribute to the field. This can lead to a lack of diversity in the field and make it difficult for new ideas and perspectives to be introduced. Finally, as with any area of scientific research, there is always the potential for unintended consequences and ethical considerations that must be taken into account. For example, the development of new technologies and applications based on the study of quarks and leptons could lead to new risks and challenges that must be addressed. History of quarks and leptons. The history of quarks and leptons began in the early 20th century with the development of atomic physics and the discovery of the electron. In the 1930s, physicists first proposed the idea of quarks as building blocks of matter to explain the structure of protons and neutrons. This idea was developed further in the 1960s by Murray Gell-Mann, who was awarded the Nobel Prize in Physics in 1969 for his work on the theory of the strong nuclear force and the discovery of quarks. In the 1970s and 1980s, the discovery of a new type of lepton, the neutrino, led to a deeper understanding of the nature of these particles and their role in the universe. The study of quarks and leptons also became an important part of the field of particle physics, with the construction of large particle accelerators like the Large Hadron Collider, LHC, in Europe, which are used to study the interactions of these particles and the fundamental forces of the universe. Today, the study of quarks and leptons continues to be an active area of research, with new discoveries and advancements being made regularly. The knowledge gained from this research has important implications for our understanding of the universe and has numerous applications in fields such as medicine, energy, and technology. What happens if quarks and leptons collide with each other? When quarks and leptons collide, they can interact with each other in a variety of ways, depending on the type and energy of the particles involved. These interactions can result in the creation of new particles, the emission of radiation, or the transfer of energy. In particle accelerator experiments, high-energy quarks and leptons are often smashed together to study the resulting interactions. These collisions can help scientists learn more about the nature of the particles and the fundamental forces that govern the universe. When two quarks collide, they can form new particles, such as mesons, or interact to produce gluons, which are particles that mediate the strong nuclear force that holds the nucleus of an atom together. Conclude. In conclusion, quarks and leptons are the building blocks of matter and are the subject of ongoing research in particle physics. The study of these particles has greatly advanced our understanding of the nature of matter and the fundamental forces that govern the universe. The benefits of this research include the development of new technologies, advancements in medical treatments, and an improved understanding of the universe. However, the study of quarks and leptons can be challenging and requires significant investments in research and technology, and there is always the potential for unintended consequences and ethical considerations. The history of quarks and leptons began in the early 20th century and continues to be an active area of research, with new discoveries and advancements being made regularly. For more videos, stay tuned with us.